What did you use for audit logging and observability pipeline in your company? For compliance, I built an audit logging pipeline where every significant system event, such as authentication attempts, authorization decisions, data access, emitted a structured log event. These were streamed asynchronously so they never blocked the request path. I implemented distributed tracing using OpenTelemetry. Every request carried a correlation ID that propagated across all microservices. That means when a security incident occurred, I could reconstruct the full request chain across 10 plus services in seconds based on that correlation ID. The observability stack fed into alerting pipelines. For example, a spike in 401 unauthorized responses from a single client or a specific client would trigger a security alert within 60 seconds. How were the audit logs streamed asynchronously? Short answer for the interview would be Kinesis data streams, not SQS. I'll explain why, then show you the code. SQS works for some async workloads but is a poor fit for high volume audit logs. Here is the trade off matrix between SQS, Kinesis data streams, and Kafka. The throughput, in terms of throughput, SQS is moderate 3000 messages per second. Kinesis data stream is high 1 megabyte per second per shard scales by sharding. Kafka throughput is very high. Now ordering SQS FIFO queues only limited throughput. In Kinesis data stream we have per shard ordering. In Kafka we have per partition ordering. Now, in terms of replay SQS, we don't have replay once consumed gone. Kinesis data stream replay is yes 24-hour to 365 days retention. Kafka replay is yes configurable retention. Multiple customers SQS is hard. Each customer needs its own queue. Kinesis data stream, yes, multiple customers fan out through shard iterators or EFO. For Kafka, yes, multiple consumers with consumer groups. Now, in terms of cost at scale, SQS is cheap for low volume, expensive at high. Kinesis data streams, it is predictable per shard pricing. Now, Kafka, higher fixed cost, scales well. Now, audit log fit, we don't have a replay or no fan out, so SQS is not fit. Now, Kinesis data stream is fit because replay for forensics fan out to S3 plus Elastic. Now, Kafka is same benefits but more operation overhead. For audit logs, replay is non-negotiable. If your Elasticsearch indexer crashes or your S3 archiver has a bug, you must be able to reprocess events. SQS deletes messages on consumption. That's wrong for audit data. Kinesis and Kafka keep events on the stream regardless of consumption. So the answer is we used Kinesis data streams as the transport. The Go service had a buffered async writer. Events went into an in-memory channel. A Go routine bashed them up to 500 records or 1 second, whichever came first, and used the put records API to push to Kinesis. Three downstream consumers fanned out from the same stream. A Firehouse delivery stream that wrote Parquet files to S3 for our 7-year retention requirement. A Lambda that indexed into Elasticsearch for the security team's hot search, and a Lambda that pushed metrics to CloudWatch for alerting. We chose Kinesis over SQS specifically because we needed replay. If Elasticsearch indexing fell behind or had a bug, we could reset the shard iterator and reprocess. SQS deletes messages on consumption, so there is no recovery. Now, the code for the buffered async writer, there is a pattern you should be able to write live. In terms of Go code, you need to write package audit import open brackets within double quotation for each letter, not each letter but word, context, double quotations encoding slash JSON, log, time, github.com slash AWS SDK Go V2 service Kinesis. close the bracket, type event struct, open the flower braces, write in the form of a table, timestamp, time.time, single quotation JSON, colon, double quotation timestamp, close single quotation, space event type string JSON event type, space enter tenant ID string JSON tenant ID, enter user ID string JSON user ID, enter write correlation ID, write result resource action source IP, type writer struct, open the flower braces, client star kinesis client stream name stream, buffer chan event batch size int flush after time dot duration, close the flower braces, func new writer client star kinesis client stream name string star writer open flower braces w colon equal to and writer open flower braces client colon client comma stream name comma buffer colon make bracket chain event comma 10,000 bracket close comma batch size 500 flush after 1 into time into second, close the flower braces, go w dot run, return w, close the flower braces. Similarly, you write function for writer which emits an event and has like a select statement within it, and then write a function for a writer which runs batch ticker, then for select we basically have batches which are appending so on. Then we have another function writer flush bracket batch comma event and so on. So basically we have these critical design decisions to call out bonded buffer plus drop on full. For audit logs, blocking the request path is worse than dropping events. The latency budget of the API matters more than 100% capture as long as you alert on drops. The metric counter is part of the contract. Shard by tenant ID. Partition key controls which kinesis shard receives the record. Tenant keyed partitioning gives you per tenant ordering and isolates noisy tenants to specific shard. Batch and flush put record batches up to 500 records or 5 megabytes. Single put record per event would be 100 times more API cost. Background go routine, one writer go routine fed by the channel, no mute access needed. The channel is the synchronization primitive.